Yeah, also welcome from my side to the weather briefing. I'm sitting here in Salzburg in the regional office. So, as Dominic introduced me, my name is Christian. I was born and raised in Salzburg. It's also where I'm working right now as a forecasting meteorologist at the regional office of the Geosphere Austria in Salzburg. Today it's cloudy because we have some fog in the area. We have right now 23 degrees here. What else? I love music, especially in form of a concert and sports, all kinds of sports. But as I said, I'm a forecasting meteorologist, and that's why I wanted to show you a little example or a case of satellite products and how they are used in our forecasting. Last week, I had forecasting shift, and I was looking at the HRV in the morning, and then I saw something that I want to share with you today. Let's talk about the HRV Cloud RGB a little bit. It's a classic, I would say. It's best for cloud monitoring and for getting an overview at maybe at the beginning of your shift, if it's not too early. The recipe is shown here on the right side. And what you can see is that for the red, we use the HRV channel, and for the green also. But then in blue, we use the infrared 10.8 inverted. Question, does anyone know what that means, that inverted part of it? You can either write it in the chat or even unmute yourself and tell me the solution if you know it. There's also, I think there is a little hint given in the recipe, but I think I will just go there. It means that higher signals are assigned to cold brightness temperatures, while lower signals are assigned to warmer brightness temperatures, which gives a little bit more detailed view on the clouds. Then it has some benefits. It gives good contrast between high and low level clouds, with some experience, I have to say, and between thin and thick clouds also, thin and thick high clouds also. And depending on the sun elevation angle, you can also very nicely see cloud top features. It has some limitations. Obviously, it only works during the daytime. Cloud top features become less visible during midday because of the sun elevation angle, and some low clouds are hard to distinguish from each other. And here on the right side, you can see the HRV image I was looking at when I began my shift last week. And I was looking at it and thought, what's like the dark spot right in the middle over Austria? And here it is a little bit bigger. When I was cycling to the office, I was like in really, really bad rain. I was completely soaked. And that's why I was wondering why there is a cloud-free area right behind the front that completely drained me like 3 minutes ago. And then I thought, like, okay, what could it be? Here you can see the radar or the precipitation from that time. You can also see can you see my mouse cursor actually? Right now I'm over Baden-Württemberg. Yes, okay, perfect. You can see there are some convective showers, and also along the front there are some convective signals. And you can also see them very nicely. Here over Germany, you can see the shadows of the convective clouds that are more higher up than the more stratiform clouds. And that's also like the gap in the clouds that you see, or that you think you see, because the convective clouds in the front, embedded in the front, are like throwing a shadow on everything that is westwards of them, because the sun is like rising in the east, and you have this really nice shadow. And it's a really nice image, I think, because it's a more or less perfectly aligned front from north to south, and then you can perfectly see the shadow over here. And if you take a look at 7 UTC, which is also already 9 o'clock local time, the front has moved forward to the east, but you can also see that obviously some of the more intense rain showers collapsed, and there are not that much distinguished cloud top features anymore. But also the showers over Germany, you can see that there is no shadow anymore, and you're having much more hard time defining cloud top features. Even though I have to say these were not really powerful thunderstorms, like you can see some overshooting tops or anything. That was not the case, but still, it's I think a really nice example for the HRV. But let us maybe focus on the here and now. And I want to give you or walk you through a small overview over the current synoptic situation over Europe. And I think we're going to use the classic RGBs we're using most of the time. We have the Airmass RGB, the HRV Clouds RGB, as I used before, and also the fog RGB. And then we have the 24-hour microphysics or the dust RGB. I think these are really some classics that I think most of the meteorologists should use or could use during their shifts, because these are more for like overview in general, not like the sandwich or the severe storms RGB, which we really use for nowcasting, but it's more for like general synoptic situation. So what I'm bringing you is the Airmass RGB from 6 UTC today. You can think for a minute for yourself what you can see here. I mean, we have the different colors in the Airmass RGB. You also see some different clouds. Yeah, maybe I show you a little bit what I was thinking about. You can really nicely see this low pressure system here over Great Britain, Scotland, and everything. You can also see this nice cold front here in the western part over the Atlantic. And also we noticed like a thunderstorm that was happening during the night in Austria and brought really some intense precipitation during the night. I think I didn't recheck it, but there was something about 80 millimeters in really a short time overnight at one station. So it was a really intense thunderstorm, but it is already in the decreasing stage of his life, and moving more eastwards to die off completely. You can also see in the different colors. We have here these greenish colors, which are indicated with this circle kind of thing. So you can see this warm area direction before the front very nicely. Yeah, and also some of the blue shades, which is more like the cold stratospheric air. Yeah, so we have like this overview. If we take a picture, a look at the same snap from 6 UTC, but with the Microphysics RGB, you can see some other features. It is really nice, the microphysics, for like the thickness of clouds or the temperature of the clouds. So you see in this brownish colors, you can see like thick, high-reaching clouds. Also this thunderstorm, as I said, in its mature state. I think I also highlighted some of it, yes. And first I thought, okay, we had some warm air direction. I indicated it in the Airmass RGB first. Maybe there's also some dust involved, because if you take a look at some of the prediction models for dust transport, you can see there's a small signal for Spain and France for today. And then I saw, okay, there are some pinkish colors, and in the dust RGB, you can see dust with the pinkish colors. But then I thought it's a little bit too broad shaded area, and it's also very confined to the landscape. You can see on the borders with the sea, you don't really have these pinkish colors anymore. And then I checked the quick guide again, and I saw, okay, no, you can also see dry air in lower levels with this Microphysics RGB in pinkish colors. So that's what you see here. And if it really would have been dust, it would have a more like a plume shaped, and it's really, really pinkish. You would see it more nicely. As I told you in the introduction, we have some very foggy conditions here in Austria, at least in Salzburg. And you can also see these low-level clouds here. I mean, you see something, right? You cannot really distinguish right now if it's like really low clouds or if it's fog. And that's why I took a look at the fog RGB for the same time. And then I thought, okay, maybe something's looking wrong here. I mean, this is the fog RGB, and you cannot really see these low stratus clouds. That's a little bit yeah, I don't know, it's kind of fishy. And then I thought again, and I thought, oh, 6 UTC is already pretty early in the day, because if you take a look here over Gibraltar, you can already see some low clouds and some fog in this bluish colors, while here in Austria or southern Germany you don't. This is because this fog RGB only works during night, or best during night, and that's why I jumped 2 hours back. So this is from from 4 UTC, and here you can very nicely see the low stratus that was over the south of Germany. And if you take a really close look, like where my cursor is right now, you can even see the Inn Valley, which is one of the most pronounced valleys here in the Alpine region, and also here the Salzach Valley in Salzburg. You can even see the low-level clouds here, the stratus deck. Then, of course, I would say my favorite, but it's just really nice to see the Earth from above with all these nice cloud features. Here in the HRV, you can really well see the foggy areas. And here is a webcam snapshot from a webcam that is located here in these Alpine valleys. And you have a really nice view over the cloud top height of this low stratus deck, and the mountains behind are like peeking out of it. It's a really nice view. That's why I love autumn here in the Alps, because it's got really nice pictures. It produces really nice pictures. Yeah, and that was my short overview over the synoptic situation and a small snapshot from my experiences with the HRV during the last week. And since Andreas has something special for you, I will hand over to him right now.
Well, yes, something completely different, atmospheric rivers. Why do I present atmospheric rivers? The reason is I've been looking for cases over Atlantic and Europe, and I found many of them, much more than I usually that I thought in the beginning. And I would like to present to you the characteristics of these atmospheric rivers. This is a phenomenon that is usually known from the States. And if you Google for atmospheric river, you will soon get some images like that, or some graphics showing some whitish cloud bands. And in the States, they call it Pineapple Express. Well, why pineapple? Because pineapples grow over Hawaii, and most of the time these atmospheric rivers come from the Pacific region of Hawaii and hit the Californian coast and bring them a lot of precipitation. But I have to say that this nice image here that should depict an atmospheric river is not a typical case, because usually, and this seems to be a visible image, usually they are not such high clouds, whitish clouds. They are much more modest in the visible or in the infrared image, and I will explain to you why. But well, this is for sure a nice example, but it's not the usual case. So let's go to a very recent example from 9 June. The question to you is now, I told you atmospheric rivers are not that clearly visible in the visible images usually. Where do you think is the atmospheric river here in this image? Can you annotate it? So look for rivers in the sky. Yes, perfect. So that's exact. All of that is exact. Very nice. Usually they are not that bright as shown in the previous image. This is coming. Yes, this here is the atmospheric river. And I agree with you, it's not easy to find. There are a lot of cloud bands here, and it's hard to detect them in the satellite imagery. You have to have additional information on that. For example, you can go to the model fields, you can make a cross-section through this atmospheric river, and then you will clearly see this low-level moisture field here. below 700 hectopascal most of the time. Well, you have moisture, excessive moisture over much of the area. But here you see there is a bulge of moisture that reaches higher regions, but seldom higher than 700 hectopascal. And there is also a clear frontal indication here on both sides of the atmospheric river, but this is only due to the moisture and not due to temperature. I will show that later. So 8 points, I have written down 8 points, but it could be 6 or 11, depends how you arrange them, that characterize an atmospheric river. And the one thing, that's what you have seen now, it's a low-level moisture band. It's not getting up to higher levels as shown in the very first image from America, from the Pacific. This is not the usual case. Usually it's below 700 hectopascal. Very important, it is rather narrow and it is rather long. 1,000 kilometers is really the maximum. The average is 300 kilometers wide and more than 2,000 kilometers long, or even much longer. You need to have a high moisture amount. And this moisture amount, there is a definition that you find in literature. The total water content, TWC, I'm sorry for writing here, the total water content is more than 20 millimeters. But these 20 millimeters have to be found in the lower levels of the atmosphere, not on the whole atmosphere. So very important, this atmospheric river is always associated to a low-level jet. So a stronger wind band that runs in parallel to the moisture band. It is located over the seas. You will rarely find, or as good as never, find an atmospheric river over land because of friction, because of the missing evaporation from the sea, which brings also water supply to the atmospheric river. But the main water supply comes from a moist tropical, a marine tropical air mass. And from this marine tropical air mass, there is a moisture band that travels to the north or to the south in the southern hemisphere. And this builds up the moisture transport in our atmosphere. There's a lot of water transported in this atmospheric rivers towards the north. Finally, my last point is, and we will see that at the end of my presentation, there is a lot of precipitation when such an atmospheric river hits land or makes landfall. We will see that in a final example. So, on the other hand, atmospheric rivers are not frontal cloud bands. So if you look at the satellite image and you find some nice cloud band, and it's a frontal cloud band associated to a temperature gradient, this is not an atmospheric river. Although, to make it a little bit more complicated, atmospheric rivers can merge to fronts, but they still remain in the lower levels. It's not prefrontal moisture convergence. This is also nicely seen in the visible or infrared images, but it's not, though it's associated to atmospheric river, but this is not the main part. It's not a warm conveyor belt for those who are familiar with the conveyor belt theory, because conveyor belts are rising air masses prefrontal to cold fronts and always associated to one frontal system. And as you can see here in the image you have here in red the hot and moist air mass of the tropics, marine air mass over the Atlantic, and due to the pressure gradients, there is a kind of filament that brings this moist air mass next to the ground. Here's a high pressure level to the north. So it's not a warm conveyor belt. The warm conveyor belt would be here prefrontal and be associated also to the warm front. This atmospheric river is not associated to a frontal system. It can move along several frontal systems and propagate to the north. So they are not found in the polar air. Here's the polar air behind, in the north of the polar front. Here's the polar front. It's always found in the tropical air mass. And as I already said, they are not connected to a single frontal system. They are going along several frontal systems. So this is a very recent example. I tried to look for an August example. I started with August the 1st, and already on August the 2nd, I found one. Here's an atmospheric river. This is a very nice example. You see the low-level clouds here in the infrared image. Yeah, and it is approaching a cold front and then attracted by the low-pressure system so that it merges finally with the cold front. So here again, we have similar vertical cross-section through the atmospheric river. You see this bulge of moist air below 700 hectopascal. And as I told you before, there is no temperature gradient. So this is not a front. These black lines here, which depict the equivalent potential temperature, is only due to the humidity and not to the temperature. Yes, the dust RGB, and Christian has shown an example in his presentation, is able to depict low-level moisture. So you can use the dust RGB to see if there is an atmospheric river. So please, again, take your pencils, and it's the same example. See where you have this bluish, darker bluish colors to see where you have more moisture on the ground. So please see where you have the excess of moisture over the Atlantic and where you would locate the atmospheric river. But this is one of the good things of the dust RGB. Yes, exactly. That's it. Very nice. Yeah, you see the darker blue, you see the lighter blue in the surroundings, and in pink you see the low-level clouds. Yeah, exactly. So you can also take the dust RGB to identify low-level moisture, which is fine. So I need to raise again, sorry. Okay, and continue. Yeah. Here it is. Yeah, that's the region you have indicated. Well, the best thing to do to really see if there is an atmospheric river, you go to the model fields. And you go here for a total column water. That means all the water that you find in the atmosphere is summarized, and you see clearly that there is a lot of humidity here. And you don't have high clouds in that area. Neither in the visible nor in the infrared, there are no high clouds. That means all this moisture is from the ground. But be careful, you will also have high humidity values here, up here, but it's the warm front. And you find humidity up to the tropopause. Here, the humidity is only in lower levels. That's why cross-sections are very important to identify the low-level humidity. So the next image shows you the low-level winds. Here, the wind barbs at 950 hectopascal. And I told you that there is a low-level jet associated to this atmospheric river. Do you see it? Please take again your pencil and indicate the low-level jet, the wind. Exactly, here it is. Yes, yes, that's it. You see higher wind speeds along this ribbon of moist air. This is very characteristic for a moisture band, for an atmospheric river. So we have plenty of them. This was the first example. Maybe there are other examples in August, but this was the first. On the second day I looked at, I found this example. So there are really a lot of them, and they not always bring precipitation to land, because they do not always make landfall. But if they do, and if they stay stationary for a longer time, you will have a big amount of precipitation. So I will delete again before I can continue. The next image shows you again the wind. Yeah, that's the region. And this here is the ASCAT. So it's a 10-meter wind from the METOP instrument ASCAT. And you see also here high wind speeds along the band of the atmospheric river. So to come to an end, why is it important for us to look for atmospheric rivers? Well, especially for coastal countries like Portugal, Spain, also England, Ireland. These are the regions which are often affected by atmospheric rivers. They have a lot of moisture, as you have seen, and if such an atmospheric river hits land or makes landfall and is lifted on the coast, then the humidity is released. And if this atmospheric river is stationary for a longer time, it can bring a lot of precipitation. Here's an example from 29 May this year, that's not long ago. You see this atmospheric river here. You see the streamlines of the low-level wind that hit the coast, and you see some synop stations reporting precipitation. Is there precipitation over the Atlantic? No, there is not. But you will not see it because this are the synop stations, and there are no synop stations over the sea. But usually the precipitation onset is over land, and only when the air mass or the river is lifted to higher regions, when condensation takes place. So what really happens over the sea is better visible in this product. This is the precipitating clouds product from the nowcasting stuff. And you see here that precipitation only starts when the atmospheric river comes over land. And you can also see that it triggers precipitation here also over Germany and even over Poland. But the main part of the precipitation usually is delivered in the coastal regions when the airflow, the low-level river is lifted to higher regions. Yeah. So this was an example from this year. If you have time, just go to ePort, check the total content, the total water content, and maybe do some cross-section, and you will see you won't look for many hours until you see an atmospheric river. They are most of the time staying over the Atlantic and not hitting land. Sometimes they hit land and deliver precipitation. So I think this concept is quite useful, not only for the United States, where you find a lot of examples in the internet, but it can be useful also for Europe. Yeah, thank you very much.